Okay, hi everybody, we're back again with a new lesson, which is Who Needs a Map? Page 506 and 557. But before we start the new lesson today, I would like to revise with you the previous lesson, which is a path to follow. I think all of you now understand what does mean of the circuit, exactly the open circuit and closed circuit. Okay, and we remember that a circuit is what? Is a path along which electric charge can flow. So for an electric device to work, the circuit must form a complete loop, if you remember that. So today the lesson is related to the previous lesson as usual. So if you are now with me, please open your book, page 506, 507. Okay. Series circuits. What does it mean of series circuits, guys? A series circuit has only one path. Okay, guys, this is the one path. Okay, that's what I mean here. When I told you a series circuit is mean what exactly? It has only a one path that the charge where can move from the positive terminal to what to the negative terminal. Okay, guys, so it has only one path for the charge to flow. Okay, guys, it only has one path. Okay, so a series circuit, it has only one path for electric charge to follow. Okay. And this is the example of what of the series circuits. Okay, guys, the series circuits is have what only one path. Okay, for the electric charge to what to flow or to follow. Okay, guys, from the positive terminal to negative terminal. Okay, guys, from here to here. Okay. Okay. In a series circuit, electric charge must follow a single path. I told you that. It's easy. We still now understand everything because everything is easy, and I think we have a complete idea about the circuit. So now we are in series circuit, and we know that it only has only one path. Okay, for that reason, in a series circuit, electric charge must follow a single path. Okay, a single path, like here. See, this one is a single path. Okay. Okay. The charged particle move from the battery's positive terminal into its negative terminal. That we know that also because it's starting from where? From here. The charge start to flow from where exactly? From the positive. Okay, from the positive part, and what move to where? To the negative part, or to the negative terminal. Okay, guys. Okay. So now here there is some disadvantages of this circuit, by the way. The disadvantages of this circuit, one of them is what exactly? If the one light bulb burns out, all the lights go out because what? The circuit is broken and open. Okay, guys, so what will happen here exactly? See, so if one light bulb, okay, it burns out, what will happen to the next one here? It will stop working. By the way, the same, it will burn out, and all the circuit will be open, because what will happen here exactly? I told you in a series circuit, every device must function for the circuit to be complete. Okay, so one bulb burning out like this one in a series circuit breaks what? Breaks the circuit. What does mean of breaks the circuits? Make the circuit open. Okay, make the circuit open. For that reason, when this one it's broken out, broken or burns out, so what will happen to the circuit? It will be open. Why it will be open? Because what will happen exactly? Okay, guys, who told me what happens when a bulb burns out? I will explain everything about this matter. I will tell you how. See, I will write the information and external document in case to understand it well, because if I didn't write it, this is a problem. So for that reason, I will open a new form. Okay, and I will start to write for you what will happen exactly when the bulb, okay, when the light bulb burns out. So if I select this one, it's enough for me. No, more than that also. Okay, to see well what I will write here. Okay, I think this, okay, it's okay. Okay, what happens when a bulb burns out. Okay, what's happening when a bulb burns out in series circuits, guys? That's what I mean. Okay, in the series circuits, what will happen if when the one bulb light is what? It's open or it's burned out. What will happen exactly? See, I told you again. Sorry. I think here, yes. So what will happen when one light or one light bulb burns out? What will happen here exactly? To understand again, I will write it for you here, okay? Change the color in case you understand well. Okay. So when the filament, you know what does mean of filament, guys, here? Okay, I will show you what does mean of filament in case to understand everything, okay, guys? So I will show you element of light. Okay, this one. See this one? Okay. This is the funny one. Okay, see this one. This is the filament. That's what I mean. Okay, this one. Okay. The lightning wire. Okay, this one. See, or this one. Okay. So when the filament breaks, what will happen? Okay, what will happen exactly? The cirrus part, or sorry, okay, this okay, cirrus circuit, or the cirrus okay, the cirrus circuit now contains what exactly? Contains something like what? An open link. Okay, guys, so when a filament breaks, the cirrus now contain what exactly? Okay, wait for what's happening here in the board. Okay, this one contains what exactly? Contains an open link. Okay, guys, something it's open. Okay, the circuit, it will open itself. Okay, so it's as what exactly? Open link. Okay, and then this open link, so this open link does two things. It causes the current to stop flowing, and what else? The remaining light go out, and it causes the full charge to appear across the broken filament. Okay, guys, this is what I mean. So it causes two things. Okay, it does, or the open link, it's what do this open link what does two things. Okay, it does what? Two things. Okay, there's a problem in the document here. It does two things. Okay, two things like what I told you. It causes, first of all, it causes the current, okay, to stop flowing. Okay, guys, to stop move or stop flowing, whatever. Okay, no problem. And what? So the remaining light, the remaining go out. Okay, guys, so the remaining go out, the remaining light go out, and it causes what? And it causes the full charge to appear, okay, to appear across the broken filament. Okay, this is the reason that make the what? If one bulb or one light bulb it's broken. Okay, so what will happen here? So what will happen if one light it's broken here? What will happen to another one? It's also what? It will be broken, and what? If the circuit will be what? It will be open. Why it will be open? Because I told you here Because I told you here is what exactly, because it causes the current to stop flowing, okay guys, and the remaining light go out, okay, because it stopped flowing the remaining current, okay guys. So it causes the current to stop flowing, okay guys. That I mean, what I mean, okay. So if we're back again to the page here, okay, here, that's what I mean. So if we back here, so see the charge coming from where? From the positive terminal here. It's move and it move. So when this one is break, okay, or it spawns out, what will happen to the light here? So the charge, the full charge will be kept here, okay guys, will be kept here, and will what? It will stop here, or will stop here. The current charge will stop here, and it will not move to the another part, because this one is apart from the path, okay guys, because the bulb, okay, the light bulb here is apart from the path here, from the circuit itself. For that reason, if this one burn out, so what will happen here exactly? So all the circuit, it will be what? It will be broken and open, okay guys, because the charge will stop here, okay, the full charge will stop here and will not move to the next what, to the next light bulb. I think you understand now what I mean, okay guys. Let's go now to the second one, or the second type of circuits. Now we finished talking about series circuits, and we're starting talking about what? The parallel circuits, okay guys. Parallel circuit is a circuit that with several different methods of what? For the charges to follow. For example, see now, this is the example of the parallel circuit, okay guys. It has what? 2 loops, okay. The parallel circuits, by the way, it's more than 2 loops, okay. You can imagine a circuit with more than 2 loops, okay, 2 or more than. This is, we call it what? Parallel circuit. If the circuit has 2 or more than 1 loop, the circuit itself has 2 or more than 2 loops, it's mean what? It's a parallel circuit, okay guys. So a circuit with several different paths. So this one the first path or first loop, and this one the second loop, okay, to what? For the charge to what? To follow or to flow, okay guys, from the positive to from negative to positive, okay guys. Okay, let's complete. If one part of the circuit breaks, what will happen here? So for example, if the light bulb it's burned out, what will happen here? That the circuit will be open, or will be closed. This one, the first loop, will be open, but the second one, no. Because why? Because the electric charge will start to move to the first one and then to the second one without what? Without stopping them, without stopping the charge, or because what exactly? Because there are what? Independent loops, okay. There are independent loops. This is the first loop and this is the second loop, but in the series circuit is what? Is dependent loop, okay. Is dependent one, okay. Dependent one because it's only one path that what? Related to the first and the second what? Light bulb, okay guys. So both of them, both light bulbs are what? Depends on one path, okay guys. This 2 bulbs are what? Depends on what? On one path. But here guys, no, it's different. Here the first light bulb is what? It depends on only its own path, okay. This one is its own path, okay. But what about the second one? The second one also, it has what? Its own path also as well. See this one. So for that reason, if it's having here any problem in the first loop, the second loop will it will work easy, okay guys. This is what we mean. Okay, if one part of the circuit breaks, the charge can still flow along the other parts, okay guys. This is what we mean here. So what will happen if that light here, it's what? It spawns out. Sure, the battery will what? Well, the charge that's coming from the battery, it will still move to the next one, okay guys, because it has here its own path, and this light also, it has its own path, okay guys. Let's complete and go to the next one. Okay, in this parallel circuit, charges can flow through both the top loop, this is one, the top loop, and what? The bottom loop, okay, this is one. and the down, the what, the down one is what, the bottom loop. Okay guys, okay, let's solve now the activity in the box. Okay, sorry, not this one, sure. No, okay, this one. Okay, I think you understand what I mean. This is example of what, of series circuits. Okay guys, series circuit is because it's what, it have a single path. Okay guys, single path, that what, that all the light bulbs depends on what, on a single path. Okay, or depends on it. Okay, so here, see now, also this light bulbs is what, it depends on what, they depends on what, on one path. Okay, for each of them. Okay, and what about this one? See now the same. Now what will happen now, it's some of them what, burns out, all of them will what, will not work well. Because why? Because they depends on what, in one path only. They depends on what, on one. Let's zoom in the page please, in case to understand well and to see everything. Okay, so if this one, if any problem happens in the first bulb light or the second or the third one, so all of them will what, will burn out, will not open, will be breaks, and the circuit itself will what, will be open. Because why? Because they depends on what, on one path. Okay guys, this one is one path. Let's go to the next page now here, and see here they give you example. You have to solve it by yourself here, but I will solve it with you. Before I will solve it, I think I explained for you here what happened. So this one is example of what, parallel circuits guys. Okay, one part of the parallel circuits breaks only, or like this one, where, which one, this one. So what will happen, only the part of the circuit stops working. Okay, and the other will work, because they depends on what, of how many lines or how many paths exactly, more than one. Okay guys, 2 or 3 or 4. Okay guys, for that reason it will still work. So this one is much better than what, than the previous one. Okay, there is an example here, by the way, before I start solving the activity. Suppose the television, that the television and all the lights in the room are part of the same circuit. Okay, we call it what, a series circuit. Okay guys, what would happen if one of the light bulbs burned out? So if the circuit is series circuit, so what will happen if you depends the television and all the lights that in your room, that work in your room, is depends on only one circuit? It's what, it's a series circuit. So what will happen to them if the light, one of the light in your room burns out? That all the lights will burn out, and also the television will not work anymore. Because why? Because they depends on what, in series circuits. But what about if they depends on what, and different what, in different paths, which we call it what, parallel circuit? The light, if one light will burns out, the other lights will still working, and the television itself will still working also. Because the parallel circuit, it's what, it depends on what, how many paths exactly, more than 2 paths. Okay guys, 2 or more than 2 paths. Okay guys, now let's start solve the activity here. Look at the circuit below, color the bulb. Okay, see here, which one of these lights will be open, and which one of them will be closed? And tell me why exactly. So this is example, first of all, this is example of what, that you have to understand that to solve this activity, you have to understand this kind of which circuit exactly, series circuit or parallel circuit. See how many loop we have, top loop and bottom loop. Okay guys, this is the top. Okay, this is the first path. See, this is the first path of the first loop. So see, if you see now, well, trace, you have to trace the path. Okay guys, you have to trace the path to understand what does mean of loop. Okay, so the positive charge starting to move to reach the negative charge. Okay guys, by what, by the switch here. Should any I think most or maybe 100% of the circuits has what, switch. Okay guys, okay, so most of the circuits have what, have switch to control the charge to flow. Okay guys, by the path. So what will happen here now, the light here will be open. See now, first of all, focus on the what, on the switch here. The switch here is open. What does mean of that? If the switch is open, it's mean what, the positive charge, it will prevent the positive charge to move to the next charge or to the next path. Okay guys, here. So here there is no path. Okay guys, see, because this one is open. Okay, this one is open. For that reason the lights here will not work. Okay guys, the lights here will what? Will not work. Okay, so for that reason, because this one is what? Why the light here will not work? The light will not work here because what? Because the switch here is open. So he asking you draw an X on the switch that it's open. Okay, this one is open. You have to what now to cross this one or to draw X. Okay, to draw X on the switch here. Okay guys, because this one is open, they asking you to draw X on the open switch. Which one? This one, which is this one. Okay guys, okay, then they're asking you to tell us about the light that will work. Which light of them will work? I told you this one, because the switch here is open, the light here will not work anymore. But what about this one? See, the second loop or the bottom loop. I told you this one is independence. Okay, independence what? Independence what? This one is independent circuit. Okay guys, this is the first loop, this is the second loop. Okay guys, or this is the first loop and this is the second loop, the top and the bottom. So this one is independent from this one. Okay, so what will happen here? The charge will move easily from here to here to the bulb light here. So this one, it will be what? It will be work. Because why? Because the switch, first of all, the switch is closed. That help the charge to move easily to reach the light bulb. So for that reason, it will be what? It will be work. Okay, there is no problems for that reason. If you trace them well, see now the circuit will now see everything is okay and the circuit is closed, so everything will work well. Okay guys, this is what I mean. I think now, so you have to write the light here will be open or it will work sure without any problem, and the light here what is off. All the lights here are what? Are off, and the switch here is open. For that reason you have to draw X here. Okay guys, I think you understand what I mean. Guys, I need from you to give me a snapshot of this page in case to see if you understand what I mean here or no. I want to see you solving here. Okay guys, so I need from you to give me a snapshot of this page. Okay guys, okay, now let's solve the activity in the booklet. Okay, here. Oh no, not here. What's happened? Okay, we didn't open it. Okay, no problem, no problem. I will open it for you. I will find it in the downloads, I think, because last time I didn't. Oh my god. Okay, okay, here. Okay, where I can find it? I think here. I think I find it here. I should find it here. The booklet. Okay. Okay. So open with me your booklet, page 64, please. Page 64. Page 64. Yes, this one is 64. Okay, so easy. First of all, they give you two definitions or scientific definition about series circuits and the parallel circuits. Okay guys, a circuit has one path. I told you this one. Okay, it has only one path for electric charge to flow. Okay guys, but what about the parallel? The parallel circuit is what? The circuit has what? Many paths. Okay, it has what? Many paths for electric charge to flow. Okay, it has many paths. Okay, see, this is the first loop, the second loop, the third loop. Okay, many paths. Okay, more than two. That's what I mean. Let's start to solve the activity here. The first one, this is one talking about what exactly? The image here talking about the series circuit or the parallel circuits, guys. See how many paths do we have here? We have two paths here, guys. It's not only one, it's two paths here. For that reason, this one, we call it what? Parallel. Parallel. What about this one, guys? Only one path. Okay, see? See here is one path connected to all of them. So this one is dependent This one is dependent path, this one is independent path, because it has two paths already. It has what? Two paths, okay guys, or two lines. See, this is the first line and this one is the second line, okay guys. So they are what? They are independent, but this one is dependent. For that reason, this one is what? Is serious, okay guys. So this one is what? Serious, okay. Sorry, this one, anyway, this one is serious and this one is parallel, okay. Let's go to the next one. Homework now. So easy here, I think. The homework, question number 1. Complete the following. In series circuit, electric charge follow a single path, okay guys. Series always has what? Single path. Single what? Single path. What about the second one? We have also, I think, the 2 or 3 4 questions, okay, but now we are in number 2 now. In a circuit, if any part breaks, the circuit is open. So this one is what exactly? Which kind of them? The parallel or the series? Sure, this one is the series, okay guys. Series, okay. Now let's go to the third one. In parallel circuits, charges can flow in what? In many loops or different loops, or only one loop? Because they're talking about parallel, so it's many or different loops, okay guys. Difference, you can write difference or many loops, it's up to you, okay. And the last one, in a circuit, if one part breaks, the circuit's still working. Even if one light burn out, or one light bulb burn out, the other light bulbs is still working or no? They still working. So this is what example of what? Of parallel, okay guys. Okay, parallel, okay. Thank you for listening and goodbye.